Hello, this is Dr. Brown. In this lesson, we're going to go into Chapter 7.4, and we're going to learn how to calculate trig functions of any angle, not just acute angles. So before, we'd been doing with angles less than or equal to 90 degrees, and actually less than 90 degrees. Now we're going to be able to talk about like tangent of 450 degrees, etc. So we're going to have a sort of an enhanced definition of the trig functions. So in this lesson, we're going to get into finding the exact value of trigonometric functions of any angle. We're going to use coterminal angles to find the exact value of a trig function. We're going to determine the signs of the trig functions of any angle in any given quadrant, whether it's 1, 2, 3, or 4. We're going to define and also find the reference angle of any angle. And then we're going to use a reference angle to find the exact value of trigonometric functions, and then find the exact value of the trigonometric functions of an angle given information about the functions. So first of all, we're going to find the exact values of trig functions of any angle. And here we're going to use this figure to, first of all, display an angle with its initial side and its terminal side. We're going to pick a point A and B on the terminal side, where B is the y value and A is the x value. And this particular angle could be anywhere. It could be over here, where theta would be defined here, and we would have a point A and B. Or it could be in the first quadrant, and we still have a point A and B. Could be the third quadrant, or it could even be an angle in which we go round and round and have a point A and B. Now, looking at the figure here, we're going to now define sine of theta for this angle as equal to just opposite over the hypotenuse is B over R. And cosine of theta is going to be adjacent over the hypotenuse equal A over R. Tangent of theta is going to be opposite over adjacent, which is B over A. And then cosecant of theta is going to be 1 over sine of theta, which is R over B. Secant theta is going to be equal to 1 over cosine of theta, which is R over A. And finally, cotangent of theta is going to be 1 over tangent of theta, which is A over B. And so here on the next sheet, we have written down all of these definitions we just described. R, by the way, is always going to be the square root of A squared plus B squared. It's basically the distance from the origin to the point A and B. If any denominator equals 0, then that trigonometric function is not defined. So here's the kind of figure we're going to be talking about if it's in the first quadrant. We have the point A and B. We have the angle theta. Notice it could be in the fourth quadrant. Theta, the terminal side, is over here in the third quadrant. For example, we've got the point 4 and minus 3, in which case A is equal to 4 and B is equal to minus 3. And we would now calculate that R is the square root of 4 squared plus minus 3 squared equal the square root of 16 plus 9, which is 25, equal 5. So R would be 5. We could now go ahead and define sine of theta is equal to B over R is minus 3 over 5. Cosine of theta is equal to A over R is equal to 4/5. And tangent of theta is equal to B over A is equal to minus 3/4. And then you can go ahead and get the cosecant, secant, and cotangent by just taking the reciprocal of these functions. Now, let's just do some more examples. Let's find the exact value of the 6 trigonometric functions of quadrantal angles. And notice quadrantal angles are angles that lie on either the x or y axis. We want to do 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So let's do this. For the first one, for 0 degrees, we choose any point on the terminal side of 0 degrees, and so we'll just pick 1 and 0. The sine of theta, sine of 0 degrees, is B over R, where B is 0 and R is 1 equals 0. So the sine of 0 degrees is equal to 0. The cosine of 0 is equal to A over R, which is 1 over 1 equals 1. Notice that cosecant theta would be equal 1 over sine of theta equals r over b is equal to 1 over 0 is undefined. The tangent of theta is b over a is 0 over 1, so the tangent of 0 degrees is 0. The secant of theta is equal to 1 over cosine, which obviously is going to be 1, which is also equal to r over a equals 1 over 1 equals 1. And notice, it's not mentioned here, but cotangent of theta is equal to 1 over tangent of theta equals 1 over 0, which is undefined. Now let's go ahead and do the angle of 90 degrees, in which we'll construct a point at 0 and 1. This would be 90 degrees, or pi over 2. So sine of pi over 2 equals sine of 90 degrees is going to be b over r is 1 over 1 equal 1. So the sine of 90 degrees is 1. The cosine of pi over 2, or 90 degrees, is going to be a over r, which is 0 over 1, which is 0. Notice that, well, let's go ahead and do cosecant of pi over 2, which is 1 over sine of pi over 2, which would be 1 over 1. It's also equal to r over b, which is 1 over 1. And then cotangent of pi over 2 is equal to 1 over, well, cotangent of pi over 2 is equal to a over b, which is 0 over 1 equals 0. And now you can see that, let's bring this up and have a little something to write on here. Tangent of pi over 2 would be 1 over cotangent of pi over 2 equal 1 over 0. It's undefined. And secant of pi over 2 is equal to 1 over cosine of pi over 2 equal 1 over 0 is undefined also. So watch out for the division by 0. Now continuing with these points, let's take the point -1 and 0. And this point would be an angle equal pi 180 degrees. And it would be a equal -1 and b equals 0. So sine of pi, the sine of 180 degrees, equals b, which is 0, divided by r, which is 1, equals 0. Cosine of pi is cosine of 180 degrees will equal a over r equal minus 1 over 1 equal minus 1. So the cosine of pi is minus 1. Tangent of 180 degrees is equal to, tangent of pi, of course, is equal to b over a, which is 0 over minus 1 equals 0. And then secant of pi is equal to secant of 180 degrees is equal to 1 over cosine of pi, which is minus 1. It's also equal to r over a, which is minus 1. Notice then that cosecant of pi and cotangent of pi are not defined because you would be dividing by 0. Finally, let's get the point for 270 degrees and r 3 pi over 2. Notice that each quadrant is pi over 2 in its size, so this angle would be 270 degrees r 3 times pi over 2. And the r is 1, a is 0, b is minus 1. So now sine of 3 pi over 2 is going to be b over r. It's minus 1 over 1 equal minus 1. Cosine of 3 pi over 2 is going to be a over r, which is 0 over 1 equals 0. Cosecant of 3 pi over 2 is 1 over sine of 3 pi over 2, which is minus 1, which is also equal to r over b, which is 1 over minus 1. Finally, cotangent of 3 pi over 2 is equal to 1 over tangent. Well, we haven't done tangent of 3 pi over 2. Let's just go by the definition. Well, 1 over tangent of 3 pi over 2. And that is going to be 1 over b over a equals a over b is equal to 0 over minus 1 equals 0. So cotangent of 3 pi over 2 is equal to minus 1. So finally, we have these tables for the quadrantal angles. And I wouldn't try to memorize these. By the way, any of these you can put in your calculator and get the same answer. Now, this is a calculation here that we don't necessarily use all that much anymore because you can use your calculator to do the calculations. But this is using what we call a coterminal angle to find the exact value of trig functions. Note, you can always check these with your calculator, and I expect you to do it on your test. Two angles in standard position are said to be coterminal if they have the same terminal side. So, let's look at this. This angle is 90 and 45, which is 135 degrees. And this is, say, theta 1. Theta 2, which is an angle that has the same terminal position, would be 360 minus 135, which is 225 degrees. Just an example of coterminal angles. Here's other examples. Well, this is exactly the example I just showed you. 135 degrees and 225 degrees. Another example is to go over A, which would be in this case 180 and 45, 225 degrees. And you could also get to the same point by going around once and then come around again, and that would be 360 degrees plus 225 degrees, which would be 585 degrees. Let's see. Yeah, that's correct. Excuse me. 180 plus 45, yeah, is 225 degrees. Then you go around another 360 and you get to 585 degrees. That's correct. Now we're going to show how we can use a coterminal angle to find the exact value of trig functions. We're going to look at sine of 390, cosine of 420, tangent of 9 pi over 4, secant of minus 7 pi over 4, and then finally cosecant of minus 270 degrees. So we're going to lay all of these out. Now we're going to use these sketches to calculate the sine of these angles or cosine of these angles. If we want to look at the sine of 390 degrees, that's obviously 360 degrees around plus 30. So that's going to be the sine of 30 degrees, which equals 1/2. Now I want you to notice that if we bring up the calculator and put it in the degree mode, and then calculate sine of 390 degrees, we're going to get 1/2 without even drawing a reference angle. Now, let's do 420 degrees, which is around once 360 degrees plus 60 degrees. So the cosine of 420 is also going to be the cosine of 60 degrees, which happens to be 1/2. Just one more time, let's calculate cosine of 420. We're already in the right mode, so this should be 1/2 again. So you can see your calculator is much faster than drawing this, but it's nice to understand about coterminal angles. Now let's go 9 pi over 4, which is around once 2 pi. And so we take 9 pi over 4 minus 2 pi, which is 9 pi over 4 minus 8 pi over 4 equal pi over 4. So its angle would also be coterminal with pi over 4. So we can, to take tangent of 9 pi over 4, just take tangent of pi over 4, which is 1. And you can do that on your calculator and get the same thing. Now, let's take minus 7 pi over 4, which is going around this much. And we can get its coterminal angle by just taking 2 pi and subtracting 7 pi over 4, which leaves us pi over 4 over here. So secant of minus 7 pi over 4 is going to be equal to secant of pi over 4, which is square root of 2. You can also get this by realizing that pi over 4 is 45 degrees, and taking 1 over cosecant, 1 over cosine of 45 degrees, which is 1 over cosine of 45 degrees is square root of 2 over 2. Flipping that over, we get 2 over the square root of 2 equal the square root of 2. If you had put this in your calculator, you would get 1.414, etc., which is the square root of 2. Then for minus 270 degrees, that is this angle, and it is coterminal with 9 degrees. So cosecant of minus 270 degrees is equal to cosecant of 90 degrees, which is 1 over sine of 90 degrees. And you remember sine of 90 degrees is 1, so cosecant of 90 degrees is 1. And this is just illustrating something I think you've already figured out. If you take any of the angles in degrees, the sine of that angle plus 360 times any integer k is going to be equal to sine of theta. This just says you can start out at theta and then go around and around 360, 720, 3 times 360, etc. Either way, and you will get the same thing. The same goes for the trigonometric function of any angle plus 2 pi, which is once around the circle, times any integer k. You'll get sine of theta, cosine of theta plus 2 pi k is cosine of theta, and so on. Now, we want to determine the sines of the trig functions of an angle in a given quadrant. Now, remember that the sine of theta is equal to b over r. Cosine of theta is a over r. Tangent of theta is equal to b over a. And then the cosecant, the secant, and the cotangent would have the same signs as the sine, cosine, and tangent. So we could look at any quadrant and figure out what the sine would be. Obviously, in quadrant 1, A is more than 0, B is more than 0. So the sine, cosecant, cosine, and secant, and tangent and cotangent, because they're either ratios of b over a or a over b, or a over r or b over r, or the reciprocal, it's going to be positive. Notice that in quadrant 2, we have a is less than 0, b is positive still, and r is more than 0. So here, the sine of theta, which is b over r, cosecant theta, which is 1 over sine theta, or r over b, are all going to be positive. The cosine of theta, on the other hand, which is equal to a, which is equal to a over r, is going to be negative. That means the secant of theta, which is the reciprocal, is going to be negative. And then the tangent, which is going to be b over a. B is positive and a is negative, so the tangent is negative, and the cotangent, which is 1 over the tangent, is going to be negative 2. You can go ahead through these and look at A or B, and then you'll find in quadrant 3, sine and cosecant are negative, cosine and secant are negative, but the tangent, which is b over a, and both are negative here, it would be positive, and then the cotangent would be positive. Finally, you get to the fourth quadrant, and the sine, which is going to be the sine b, is going to be negative. The cosine, which is going to be the sine of a, is going to be positive. And then finally, the tangent is going to be b over a. One is positive and one is negative. And so the tangent and the cotangent are negative. Now, let's just test your understanding of the sine of the various trig functions in various quadrants. If sine of theta is negative, that means it's the sine of b, which is going to be negative here and here, and the cosine is less than 0, which means that if cosine is less than 0, then the a is less than 0, so it's got to be in the third quadrant. And so here's the answer. If sine of theta is less than 0, theta lies in either 3 or 4. If cosine of theta is less than 0, then theta lies in quadrant 2 or 3. Therefore, theta must lie in quadrant 3. Find the reference angle of an angle. This is a definition you probably need to understand, but I'll tell you, using your calculator, you can calculate the trig functions of the angles that you need. If theta denotes an angle that lies in a quadrant, the acute angle formed by the terminal side of theta and the x-axis is called a reference angle for theta. So, here's an example. Here's your angle theta. The reference angle is between the terminal side and the x-axis, and it looks like this would be a 45-degree angle, or pi over 4. If the angle goes all the way over here, the reference angle is the acute angle between the terminal side and the x-axis, and here again it would be about 45 degrees. Finally, if you go all the way around, the reference angle would be here, and then of course, suppose you had a negative angle that went this way, and this is the terminal side, this would be the reference angle. So now you know how to find the reference angle. For a 150-degree angle, its reference angle is 30. For a minus 45-degree angle, its reference angle is 45. For an angle 9 pi over 4, which happens to be once around plus pi over 4, the reference angle is pi over 4. For this page, we have a main angle of minus 5 pi over 6, and its reference angle is pi over 6. You can calculate that by realizing that 180 degrees is equal to pi, and we want to subtract 5 pi over 6 from that, which is equal to 6 pi over 6 minus 5 pi over 6 equal pi over 6. So here's a reference angle for an angle of minus 5 pi over 6. Now we're going to show how to use a reference angle to find the exact value of a trigonometric function. We're also going to show that you can do it with your calculator. Here we're going to find sine of 135, cosine 600, cosine of 17 pi over 6, and tangent of minus pi over 3. Let's look at each example. To do 135 degrees, its reference angle is 45, and in that quadrant, we know that the sine of the angle would be positive. So the answer is sine of 45 degrees, which is the square root of 2 over 2. If you stop the video and put sine of 135 degrees in your calculator, you will also get the square root of 2 over 2. What you'll probably see is 0.707, which is a numerical value of the radical square root of 2 over 2. Now for 600 degrees, we go around once plus 180 plus 60 degrees. And so the reference angle is 60. And we know the cosine is negative. So if we take minus cosine of 60 degrees, we'll get minus 1/2. But I want you to see that your calculator, if you take, make sure we are in the degree mode, and now take cosine of 600 degrees. You won't even have to waste your time finding the reference angle. It is going to be minus 1/2, which is what we expect. Now, example C here, we want to find cosine of 17 pi over 6, which is going around once plus 5 pi over 6, leaving pi over 6 on this side. The cosine of that angle is going to be negative, so if we take minus cosine of pi over 6, we get minus the square root of 3 over 2. But let's go ahead and put cosine of 17 pi over 6 in our calculator. We have to change it to radian modes. And cosine of 17 pi divided by 6 equals 0.987 0.987 So we can see if we put cosine of 17 pi divided by 6, that we will get negative 0.866, which you will find is equal to minus the square root of 3 over 2. Now, for the last one, in calculating tangent of minus pi over 3, the reference angle is pi over 3. The tangent is going to be negative in the fourth quadrant, so we just take minus tangent of pi over 3 is minus the square root of 3. And if we did that in our calculator, we would get exactly the same thing, but we would get minus 1.732. Now, let's look at some problems where we find the exact values of the trig functions of an angle given the information about the functions. Suppose we're told that the tangent of theta is minus 4 and the sine of theta is less than 0. Find the exact value of each of the remaining trig functions of theta. Well, we can construct an angle in which the angle is here, the value of A is 1 and the value of B is minus 4. The tangent then would be minus 4, which is B over A. And notice sine of theta is equal to B, which is minus 4 over R. Notice that R is the square root of 1 plus 16 equal to square root of 17. So the sine of theta would be B over R, which is minus 4 over the square root of 17, which is minus 4 square roots of 17 over 17. So there is sine of theta. Cosine of theta would be equal to A over R, which would be 1 over the square root of 17, which is the square root of 17 over 17. Tangent of theta, as we already know, is minus 4. Cosecant of theta would be 1 over sine, which would be minus 17 over 4 square roots of 17, which is equal to minus square roots of 17 over 4. Secant of theta would be 1 over cosine, which would be 17 over the square root of 17 equals square root of 17. And cotangent of theta would be the reciprocal of tangent of theta, which is minus 1/4. And that is the lesson for today.